The goal of our video will be to demonstrate the equation of motion F equals ma with an off-axis and friction force. To accomplish our experiment, we will have two masses connected by a thread. When we drop mass A, provide a tension force over our frictionless pulley, and the tension will pull mass B down our track. Friction will occur between the surface of the block and the surface of the track. Both surfaces are covered by paper. To record acceleration and position, we'll be using a Vernier motion detector, and our data will be logged in the computer using the program Logger Pro.
Now we'll be going over the calculations involved in conducting our experiment. We'll start with our given and our find. So we have a given mass of the two blocks. We have the angle at which the tension is applied to the block, and we have our coefficient of kinetic friction between the two paper-covered surfaces. And the goal of these calculations is to find the instantaneous acceleration of our block B. And when we get that value, we will compare that result with the results of our experiment. This is the diagram of our apparatus, the free body diagram with the forces drawn and our coordinate system. So we isolate each block from the rest of the system to analyze the forces that are applied to it. So for block B, we have the force of friction in the negative x direction. We have our tension force, a normal force, and our weight. And for block A, two forces, only the tension force and the weight. Now we'll dive into the calculations involved in our experiment. We're supposed to use Newton's second law, force equals mass times acceleration, with our friction and our off-axis tension force. So we split up the forces into the forces on block B and the forces on block A. So summing the forces in the x direction, we're going to find the acceleration of our block B in that x direction. So examining the forces, we have force of friction, our tension acting in the x direction, and then our massive block and our acceleration, which we're solving for. So separating our force of friction into the mu kinetic, coefficient of kinetic friction, and our normal force, then the rest of this is the same here. Splitting up our normal force, we have the weight of the block and the tension counteracting it to account for. And so we enter these values, our 0.28 for our coefficient of friction with the paper on paper, and we arrive with an equation that has the tension and the acceleration as our variables. So moving to the analysis of block A, we sum the forces in the y direction to arrive at our acceleration of the block A in that direction. We see here the acceleration of our block B in the x direction is the same as the acceleration of our block A in the y direction. So we're going to solve for those together. So we only forces in the y direction for this block, the tension and the weight. Tension, weight is mass times gravity. We enter these values, again, another equation with tension and acceleration. We solve these two simultaneous equations in the calculator to arrive at our calculated value of the acceleration of our block of 4.09 meters per second squared.
Now we will release block B from rest and record its acceleration. To find instantaneous acceleration from our experiment, we're going to analyze the data we recorded in Logger Pro. If we look at our velocity time graph, we can see that block B started moving around 0.69 seconds. We compare that to the data we recorded in our data table, around 0.69 seconds. It shows that instantaneous acceleration is 4.04 meters per second squared. More accurate method to come up with our instantaneous acceleration would be find the slope of velocity when the block started moving. So we applied a linear curve fit on the slope of velocity when the block started moving, and it came out to be 4.24 meters per second squared. Go.
When we examine the results of our experiment and our calculations, we see that we arrive at a very reasonable percent error of 3.67. So I was very pleased with the results. A couple minor possible sources of error do exist in this experiment, as in any experiment. A couple that we thought of was in measurement. Our tape measure is only accurate to 1/16 of an inch, so measuring the angle, that angle is going to be slightly different than the actual angle. Also, the coefficient of kinetic friction value, we looked that up for paper on paper, 0.28, but given there's many different types of paper and some other variables, that is somewhat of an estimate. So there were a few possible sources of error, as in any experiment, but we did do our best to minimize those. And as you see, we came up with a very reasonable comparison between our calculation value and our experimental value. In conclusion, this experiment was designed to demonstrate Newton's second law in the situation of friction and an off-axis tension force. Hope you enjoyed how we demonstrated this procedure and the experimental calculations. Thanks for watching.